This is section 6.5 in your student journal. We're working on logarithms. Today we're going to be working on the change of base formula. This is at the bottom of page 176 in your student journal once again. Alright, so the change of base formula says if A, B, and C are positive real numbers, B cannot equal 1, C cannot equal 1, then if we have log base C of A, it's the same thing as log base B of A divided by log base B of C. Okay, we can make this base anything. We can make a base 10, base 5, base 3, base a million, whatever you want. So a lot of times we just make it base 10. Remember, if there's no base shown, then it's automatically base 10. So therefore, we can think of it this way. If I wanted to just go with a base 10, I don't have to even put a number there. So log base C of A is going to be log A divided by log C. I could also use a base of E. Log base E of A is the same thing as natural log of A, because log base E means the same thing as natural log. So if I want to, I can do natural log A divided by natural log C. It all works out. Let's take an example. Suppose we're trying to just do a pretty simple problem. Let's say we're doing log base 3 of 81. You should know this answer right off. Here's how we know it. We think 3 to what power would give us 81. Remember how we switch back and forth between logarithm and exponential form. I would think of this as I start with my 3, I swirl it around and go to the x, and come back to the 81. So I know the answer should be 4. But watch how I could have used my change of base formula. With change of base, I can change it to base 10. I can say that this would be equal to log 81 divided by log 3. Now I can't do that problem unless I have a calculator. But I can get my calculator out and I can just do log 81 divided by log 3. And it gives me that answer of 4. I also could have done the natural log. Watch this. Natural log is right here. It's under my log button. So I could have done the natural log of 81 divided by the natural log of 30. And that's also going to give that same answer of 4. So we have lots of options there with our change of base formula. If I have an easy problem like this, there's no reason to use the change of base formula. But we're going to be doing problems where it is necessary to use it in order to be able to solve a more complicated problem. Because if I had asked you log base 3 of 80, you would know that answer should be close to 4, but not quite. We don't know exactly what it is. So to do that, I can go back up to this one. I'm just going to edit this one. And I'm going to change it to log 80 instead. And see what our answer is? 3.99. But it's not exactly 4. It's a little bit smaller than 4. All right, let's take a look at some more problems now. This would be an approximation, so we use the squiggle equal signs. Okay, so let's take a look at page 180. Hold on. Yeah, 178 rather. Look at page 178. So if I'm doing a problem like this, I can certainly estimate it. 3 to what power is 17? Well, I know 3 to the second is 9. I know 3 to the third is 27. So I know that this answer to this has to be somewhere in between 2 and 3. But I'm not exactly sure what. So, we have our calculator. We use our change of base formula. This is going to be our base. So our B value is 3. Our A value is 17. And we can just type it in. Log 17 divided by log 3. Let's type it in. Log 17 divided by log 3. If I didn't get an answer between 2 and 3, I would know maybe I put these in wrong. Sometimes people do it the wrong way. They do log 3 divided by log 17. That gives me an answer that's not between 2 and 3 like I expected, so I would know I put it in wrong. This is the way it should go in. So our answer is approximately 2.58. Okay? Same thing on this one. Let's just go down to a fraction. When I think of this, 7 to the 0 is 1. 7 to the first is 7. So if 7 to the 0, we look this a little more, if 7 to the 0 is 1, this is less than 1. This number right here. So I know that my answer has to be something even less than 0. I'm going to use natural log this time. I could type this in the natural log of 4/9 divided by the natural log of 7. 7's our base. So I can type this in, natural log 4/9 divided by natural log of 7. I don't have to do it this way. If you don't like the natural logs, just use the log base 10. Just to show you it wouldn't matter. We get the same answer no matter what base we use. So the answer is negative 0.42, and that seems reasonable. Okay, so just doing this last one. You know, another thing I could do is I could use my properties of logarithms that we talked about. We could even do it another way. Let me show you this way. I could think of this as log base 6 of 1 minus log base 6 of 10. Remember how I can do that? If I have division of two values, it turns into the subtraction of two logs with the same base. But this isn't an easier way, is it? Because now I have to do this. Now, here I want to show you another way you can do the change of base. All right, this is pretty cool. If you go on your math, and I'm looking for log base, there it is. This is really nice with these newer calculators. Instead of using my change of base formula, I can just type in log base. See what it does? It asks me, what's your base? And go back to that math. Scroll down there, I think it's letter A. Log base 6 of 10. And I can get that answer. But it would have been a lot easier just at the very beginning. Let's jot this down first. Negative 1.29. But it would have been easier at the very beginning just to do our math. Go down here to log base. And just do log base 6 of 1/10. Okay? That would give us the correct answer too. Just kind of showing you all the different ways that these logarithms work. As long as you use the correct property, you're going to get the correct answer. All right, let's look at some application problems. Number 18, it says for a sound with intensity I in watts per square meter, the loudness, L of I, of the sound in decibels is given by the function L of I equals 10 log I divided by I sub O, where I sub O is the intensity of a very audible sound, about 10 to the negative 12 watts per square meter. We hardly ever have like complete silence. You're always going to hear something. So this will be something that you can just barely hear. Completely quiet, it might just be like the sound of the furnace running. The intensity of the sound of a certain children's television show is half the intensity of the adult show that is on before it. By how many decibels does the loudness decrease? This is a pretty tough problem. There's an example of this in your book too, if you want to look it up again. But I'm going to go through it, and if you don't understand it, you can always look back at the book. So if I want to find the difference in this decibel level, I'm going to say that difference is going to be equal to L of 1/2 I minus L of I. See, I is the intensity of that adult show. And then it says the children's show is half that loud. So we have to use that the I value is going to be half as much. But in order to figure this out, I've got to now use this formula for L sub I. Right? This is going to give me the difference. I want to subtract, I want to do the, actually I want to have this one first because it's louder. Let's put that one first. So we would want to do the loudness of the adult show minus the loudness of the children's show. Because that's going to give us the difference. That makes more sense that way. Okay, so I have to compute this. Well, they give me this right here. L of I is 10 log right here. So the difference is going to be, L of I is just going to be this, so it's going to be 10 log I over I sub O minus, and now this would mean wherever I have an I have to replace it with 1/2 I. So this is going to be 10 log 1/2 I over I sub O. Alright? And so now, to figure this out, I'm going to have to do the problem. I'm going to factor the 10 out first. Okay, now here's kind of the trick with this. See how close these are to being alike? Okay, so I'm going to do this. I have 10 log I over I sub O minus. Now, if I have 1/2 times this, which is what I have, this is going to be minus parentheses log 1/2. Since it's multiplication, it turns into addition log I over I sub O. That's what I would have now. But look at this. See how these two match exactly? So when I distribute that negative through, those two are going to cancel. Okay? So stay with me on this. I know this is a challenging problem. So I'm going to have 10 log I over I sub O minus log 1/2 minus log I over I sub O. Well, I have log I over I sub O minus log I over I sub O, so that's going to be 0. So now my answer, this is multiplication, is going to be negative 10 log 1/2. So I'm going to type that into my calculator then. It's going to be negative 10 log 1/2. I put an extra parenthesis. There we go. All right, so that's going to be 3. So let's look at our units. By how many decibels does the loudness decrease? And that would be by 3 decibels. Okay. I know that was a tough one, so let me go through it again. First of all, I had to decide which was louder, the adult or the children. So the adult was louder. So I put that first, and I subtracted the decibel level or the loudness of the children's show. Then I used my formula, and wherever I wanted to do L of 1/2 I, I had to replace I with 1/2 I, and then I factored out the 10. I had this, and I had this. At this point, I noticed that these I over I sub O's matched, but this 1/2 was kind of a little extra. So I said, well, it would be minus, and then what do you do if you have the multiplication? So I really had this times this, that turns into the addition of 2 logs. Then I distributed, and then I canceled, and then I just figured it out. All right, those are tough. Let's look at the last one here. Hicks' law states that given n equally probable choices, such as choices on a menu, the average human's reaction time, t in seconds, required to choose from those choices is approximately t equals a plus b times log base 2 of n plus 1, where a and b are constants. If a equals 4 and b equals 1, how much longer would it take a customer to choose what to eat from a menu of 40 items than from a menu of 10 items? Well, t is our time it's going to take. So we need to know what's the time it's going to take if there's 40 items versus what's the time it's going to take for 10 items. Well, I'm just going to do this as 2 separate problems. The time it's going to take if we have 40 items equals a and b are constants. They tell us that a is 4, so we're going to plug in 4 for a. It tells me is 1, that's not going to change anything. Log base 2, and n is the number of items. So we have 40 items. 40 plus 1 is 41. So let's see what the time is if we have 40 items. Just need to use our calculator here. So 4 plus, I can either use my change of base formula. Let me use that this time. Log 41 divided by log 2. Oh, sure. There's an extra parenthesis again. I'm used to those older calculators. So 9.36 seconds that it's going to take there. Is this minutes or seconds? Seconds. That's pretty quick. I don't think I can do that. If I had 40 items, it would take me a lot longer than that to decide. All right. Anyway, versus 10 items. So now we would do 4 plus log base 2. 10 plus 1 is 11. We'll do this one a little differently. 4 plus, and we'll go to that math. Log base. Same thing now. 7.46 seconds. So the time for 10 items, 7.46. Alright, so then how much longer? You just need to subtract those two. Watch what you can do with your calculator. You can just go up there, get that answer, minus, go up here, get that answer, enter, about 1.9 seconds longer. To me, this should be in minutes. It would take me, if I had 40 minutes to choose from, it would probably take me a good 10 minutes, not 9.36 seconds. But that's what they say. So, there we go.